Hello everybody, this is Best Practices for Building Interactive Applications with AWS Lambda. My name is Ben Smith and I'm a Principal Developer Advocate for serverless here at AWS. And before joining AWS, I was a web developer for about 15 years, working mostly with PHP. So that will give you a little bit of an insight into some of the types of applications I'm going to talk about over the next 30 minutes or so. So this is what I want to cover. I want to talk about what do I mean when I say an interactive application on Lambda. And in order to understand that, I'm going to talk a little bit about the difference between synchronous and asynchronous and what happens when you invoke Lambda synchronously and asynchronously. I'll spend a lot of time talking about accessing business logic within your serverless applications. That means really accessing your Lambda function code. And we'll talk a little bit about how you can optimize that as well. So today's focus is Lambda-based applications, but more specifically, interactive Lambda applications. So for the purposes of this talk, that is anything where your Lambda function is invoked using an HTTP request and sends back an HTTP response. And so this is a synchronous Lambda invocation. What do I mean by synchronous and asynchronous? Okay, so here's an example of a synchronous command where a client sends out a kind of invoking command to service A. Service A will receive that. It might invoke something else downstream to service B and wait to hear back from service B. And then when it's received that information back from service B, it will finish processing and send the result back to the client. Whereas the same workload run in an asynchronous mode will look more like this, right? The client will send a request to service A. Service A will send back an acknowledgement that it's got the request, and then the process will continue on downstream asynchronously. And the key difference here is represented by this pink line. This is blocking time, right? This is how long the client is waiting to hear back from that service A before it can move on to the next procedure. So that in a nutshell is kind of the difference between synchronous and asynchronous. Now, you can invoke a Lambda function synchronously or asynchronously. There's also other types of invocations such as event source mapping, but I won't go into them and in any detail in this particular talk. So when you invoke a Lambda function synchronously, it's basically when you expect a response from your Lambda function, okay? And when you invoke it asynchronously, you're not expecting a response, you're just expecting to get an acknowledgement that your Lambda function has received that invocation request. And you can understand why that happens and how that works by taking a little peek under the hood inside your Lambda function execution environment, right? Here's a really high level representation of what that looks like. So when you invoke a Lambda function synchronously using something like API Gateway, what actually happens is that request gets proxied on to something called the Lambda front-end API. Now this is completely obfuscated to you, the user, okay? It's all happening within the Lambda environment. So that front-end API will then find an available execution environment or send a request on to the service to find that execution environment and spin one up if there's not one available. It will then run your code and return you back the response. Now this is useful if you need an immediate response from your Lambda function code. And it's also useful if you need to see what the errors are from your Lambda function code, right? And it also throttles when you hit a concurrency limit. Now, in contrast to that, if I invoke Lambda asynchronously using something like EventBridge, for example, it still goes through that front-end API, but that request is then actually put onto an internal queue, and it will stay onto that internal queue for up to 6 hours, and Lambda takes that invocation off the queue when it's ready to process that for you. Now, if Lambda, for some reason, if your function isn't able to run, it will put that message back onto the queue and it will retry up to 2 times. So that's 3 invokes in total. And then you can forward that error off to a dead letter queue if you so wish. But that's the difference. There's actually a whole other component called this internal queue that sits inside the Lambda service. And that's how we are able to do this asynchronous invocation for you. So how do you choose between running your Lambda function or invoking your Lambda function synchronously or asynchronously? Well, I think there's one simple rule to follow really, is that do you want to have to wait for a result? And in many applications, you will need to wait for that result. And in many applications, you actually won't. So if you do need that response or that result from your Lambda function, then that's your synchronous invocation. If you don't, that's your asynchronous invocation. Now, it's probably worth mentioning that a synchronous Lambda invocation can still kick off multiple other asynchronous backend workloads. So for example, I can invoke my Lambda function synchronously using something like API Gateway, and that Lambda function might then send a message on to an external service such as Slack, or it might invoke a step functions workflow and not hang around to hear the response back from that workflow. It might put something on an S3 bucket without waiting to see the result. So you can mix and merge these different workload types, of course. Now, interactive Lambda functions can fall, an interactive Lambda function application can be many different types of application, right? Some of which are listed here. These are various use cases that we see customers building out interactive Lambda applications, connecting different applications together, using Lambda as kind of glue code between two external services, extending an existing on-premise application maybe. You can use Lambda, as I mentioned, to kick off asynchronous workloads. It's great for machine learning inferencing, for back-end applications, data processing, chatbots, IT automation, Alexa skills. The list is almost endless, to be honest. I'm going to focus on this first example because I think this is a really nice, simple, straightforward way of using Lambda for an interactive application. So here's a little application that I've built that allows you to ping a Slack channel when there is a new like on a GitHub repository. And there's actually a whole blog post around this that walks you through how to build this yourself from start to finish. The link is available here. So what this does is whenever someone puts a star on a GitHub repository that I've applied this application to, that will then create this message in a Slack channel for me that looks something like this. And it says, hey, there's a new GitHub star on your repository, and this now has 10 stars, and it tells me who made the star in GitHub. Here's that application in motion just really quickly. So on the left-hand side here is my Slack channel, and on the right is my GitHub repository. And you can see I click here on the star in my GitHub repository, and but a couple seconds later, that shot a message straight in to my Slack channel to let me know that someone's interacting with my GitHub repo. Okay, what happened there? Let's have a look at it. So first of all, there is some business logic. Business logic is loosely termed as doing something to some data, some input to produce some kind of a valuable result. So where's the business logic in this little example here? Well, GitHub is sending an input to my process, which is my Lambda function, which is sending an output onto Slack, right? So the business logic is my Lambda function. The input payload is sent by the webhook mechanism of GitHub, okay? And here's a subset of that. It contains things like the name of the repository, the number of people that are currently clicked on the star icon, and who did the actual action. And this is all sent in from GitHub using the GitHub webhook mechanism. To access that event object in my actual business logic, so I'm zooming into my Lambda function code here, I have something called the event object. So inside the event object, I can access all those different variables by using a key value pair, right? So I am constructing my business logic using that event object, and I'm making a new JSON object called message, which contains information that I'm going to post to my Slack channel. And I'm pulling out of that input payload, that event object, useful information from GitHub. So I still have my input, my process, and my output. These things don't change when you're building with Lambda. Finally, I return the response. So I return a 200 status code and the result of my response to GitHub. Now in the middle of that, I'm using Axios, which is a JavaScript library for sending out HTTP requests to post out of my Lambda function environment into the Slack API to send a message to Slack to say that there's a new item or new star on my GitHub repository. Now, here's the missing piece in all of that. How did the input payload get from GitHub to my Lambda function? I had to open up my Lambda function code to GitHub in some way, right? And I used API Gateway in this initial example. So I simply provided the GitHub webhook mechanism API gateway generated URL to access my function code. And this is a common way we see people building out interactive Lambda applications. Now, customers were looking for other ways to kind of access that business logic inside their Lambda function. Maybe you don't need some of the additional features that API Gateway offers you. You just want to invoke your function code as quickly and as simply as possible. That's when we introduced something called AWS Lambda Function URL. So this is a far simpler way of invoking your Lambda function code synchronously using an HTTP request. And here's what a function URL looks like, okay? So it's HTTPS, a uniquely generated URL ID, .lambda-URL, the region that you've created your function in, .on.aws. And you can get more information about function URLs from this link available on the screen here. Now, Lambda function URLs is part of the Lambda service, and it's this new way of accessing your Lambda function code, accessing that business logic. It's its separate CloudFormation resource, and it generates this unique URL to invoke Lambda. And you can even point it to the latest or to a user-defined alias. So because this is part of the Lambda service, this simplifies my little application here. I now no longer need to invoke Lambda using API Gateway. In this particular simple instance, I can go directly from GitHub via a function URL to my Lambda code and have my Lambda function code send out to Slack. So let's have a little look about function URLs. This is relatively new. They've been out for about a year now. You can create a function URL using the AWS Management Console, using the AWS CLI, using an infrastructure as code template such as CDK, SAM, CloudFormation, Terraform. There's multiple different ways. Now, to invoke my Lambda function, all I need to do is send an HTTP request to that function URL. And of course, I can do that from a browser window. I can do that with a curl command or via Postman or even programmatically using the API. Now, customers also want to make sure that their business code is not just out there on the internet available to anyone to invoke. So there are authentication options to secure your function code if you're using function URLs. Now, they come secured as default with IAM permission. So you can use IAM to authorize requests to your function URL, or you can optionally disable that completely and have that open if you want an open API URL. And you can even roll your own authorization with code inside your Lambda function, okay? You can also add CORS configuration, which I'll talk about in just a moment. So if you want to apply IAM authorization to your function URL, you need to know about some of the new actions that are available. So there's new actions for function URLs to be able to create a new function URL config, to update your function URL, to delete it, to get information about it, to list it. And here's the key one here, to invoke a function using function URLs. This is what you have to grant to an IAM permission that you want to apply to enable to invoke Lambda using function URLs. And here's an example of me using that in a real IAM user. Now, if you've ever built web applications before, you've almost certainly seen this error. And if you've built applications using Lambda and API Gateway, I'm sure you've seen this error at some point. It's the dreaded CORS error. And my friend Eric Johnson, my good friend who's talking today, I think, he's once been quoted as saying, if CORS had a face, I'd punch it in the nose and I'd be right behind him holding it down. Eric Johnson is a fantastic principal developer advocate for serverless. He's built a lot of applications using Lambda and API Gateway. And so he knows this is a common problem or a common error message that people get. Now, function URLs goes a long way to helping to resolve this. It enables you to configure CORS very simply, right? So you can do this by just it adds a header for you automatically to your response, or you can manually roll your own. Some other things that you need to know, right, is how do you access paths? How do you access methods and query string parameters? Are these things that you can still use when working with function URLs? And the answer is yes, you can. So let's take this as an input payload. This is an HTTP request to invoke my function URL, and here's all the payload as part of that request. So let's say I wanted to access the path of this HTTP request. Well, that would be inside this object or this key called raw payload. So let's say I invoke my function URL with /mountain/Japan/Hokkaido. And then I want to access that path. Well, I can access that via the event object that we looked at earlier. It's just event.rawPath, and then I get mountain/Japan/Hokkaido. If I want to access the method, well, that's inside the http.method key, so I can access that in the same way by doing http.method. If I want to access parameters, then that's inside the query string parameters.mountain key. Okay, and I can access that from my event object as well, just like this. Another thing that Lambda function URLs does is it infers a response format for you. So if your function returns a JSON or no status code, then function URLs will refer the status code 200, it will infer the content type as application JSON, and it will send that along with the function body response. It will look like this, right? So here's a typical response payload. All I've returned from my function code here is the string hello world. But what actually gets returned in the Lambda response is a status code. Hello world string gets put inside a body key, and then it returns headers and base64 encoded files as well. So it enables you to kind of nicely standardize those responses. Now, if you want to make your own custom response, you can do that quite simply by adding your own status code. So here I add a status code of 201, and then it returns exactly the response that I've set it to return. We also have new ways of monitoring your function URLs, of course. So you're able to monitor things like the 4x, 5x, and URL latency, and you can also monitor the request count as well. Now, here's some interesting points to bear in mind if you want to start building with function URLs. There is a 6 megabyte response and request payload size limit. It defaults to 1000 and goes all the way up to 10,000 TPS, and it has a 15-minute timeout. So what that means is you can now access your Lambda function code with no additional cost, because function URLs has no additional cost associated with it. No additional timeout limits, because it can run function URLs have a limit of 15 minutes, same as Lambda, okay? So it doesn't add any limits to you there, and no additional payload limits, because that's also in line with Lambda. All this is because function URLs is part of the Lambda service itself. It's not a separate service with its own limits. So going back to my different use cases, this was my favorite simple use case for an interactive Lambda function, just as a kind of simple webhook mechanism to connect one application to another. And now with function URLs, I can do that without much complexity at all. I can also use something like the fan out request response model, where I can send in an invocation to Lambda using function URLs, send an acknowledgement back of that request, and then send that downstream to an SNS topic, which allows me to fan out to multiple other Lambda functions. So this would enable me to do something like resize an image concurrently to multiple different sizes. I can do something like high volume data ingestion, where again I invoke my Lambda function asynchronously using my function URL. I can send errant responses to a dead letter queue, and then send everything else on to Amazon Kinesis, where I can use that as my data ingestion point. I can use it for machine learning inferencing in a synchronous mode. So I can invoke Lambda, have Lambda grab down some ML models and frameworks, run that against my input payload, and return the response, because Lambda function URLs, remember, can run for up to 15 minutes. Also, it's an ideal use case for web applications and web frameworks, right? I can now invoke my Lambda function directly. So what that means is I can route everything directly to Lambda, and inside my Lambda function, I can have my router.php or my router.js to route off to the correct script, right? And I can now do all of that inside of Lambda without an additional service. I can even put it behind a CloudFront service, a CDN, so I can cache data, static data at points nearer to my user for a more responsive experience. And I can go further by adding rules in CloudFront that say if the request is looking for a static assets such as images or CSS files, then I can go directly to S3, an object store, to attain that. Whereas if my request needing some computational logic, then I can go ahead and invoke my Lambda function. So thereby I'm kind of decreasing the amount of times that I need to invoke Lambda. Lambda is optimized for running compute, okay? So if you need to access a resource that is static, that doesn't require compute, there's other services that are better kind of positioned to do that for you, right? And of course, S3 is one of those services. Now, I don't want to leave out other synchronous ways of invoking your Lambda functions. They still absolutely have value. So let's have a look at other ways that I can access that business logic synchronously to create interactive Lambda-based applications. So the first one I want to look at is Amazon API Gateway. So this is using REST APIs. The next is Application Load Balancer, and I want to compare them a little bit to function URLs. So we have this service called Application Load Balancer, or ALB, and this allows you to create groups, which are essentially collections of resources. Now these resources could be EC2 instances, or they could be Lambda functions. And what you are then able to do is to create a listener to define which of those groups are mapped to each request. And you can also run health checks on each one of those groups to make sure that they are still serving your function code. So here's what that looks like, right? You can set up listeners that will route those requests according to port, protocol, and path. So you can route anything coming in on HTTP 80 to go to your EC2 instances in group 1. You can route anything that is /order for an additional microservice that you might be building out to go directly to a Lambda function in group 2. So what ALB allows you to do is to start kind of slicing away part of your application that might be in pre-existing EC2 instances and build out new kind of microservices such as APIs or small microservices in a Lambda function. And you can route them effectively to both of those different group types using Application Load Balancer. Okay, then we have Amazon API Gateway. Now this is a huge service, very mature service, which has entire talks dedicated to it. But I'm just going to touch on some of the key differentiators really with function URLs. So this allows you to create both REST and WebSocket APIs. So there's already a point of difference there. It supports something called VTL, Velocity Template Mapping, which allows you to invoke or to access other services directly from API Gateway without any code in between. Okay, it's just velocity template language in between, which allows you to kind of remap the request as it comes into API Gateway before it gets passed on to the next service. API Gateway also supports parameter and payload validation before invoking the next service, and it has multiple different authorization options. So it's not just limited to IAM, you have lots of other ways of authorizing your request using Amazon API Gateway. So here's an example of a serverless application that uses API Gateway, where you have API Gateway with native integrations to things like DynamoDB and AWS step functions, and then other requests going directly to a Lambda function for that synchronous response mode. So here's a comparison of all of these together, okay? With API Gateway, I can not run HTTP requests, it's HTTPS only. With Load Balancer, I actually can run HTTP requests into that. Function URLs is also HTTPS only. So there's an interesting point of difference for Application Load Balancer. In terms of authorization and authentication, well, Function URLs gives me IAM authorization, and I can roll my own in code using a SIGV4 sign request. Whereas API Gateway, I have multiple different ways of authenticating. Application Load Balancer, I don't have those same options. In terms of payload limit, when used with Lambda, they're all the same because it kind of defaults to the Lambda payload limit. The maximum timeout is perhaps the most important point of difference here, okay? So with API Gateway, requests will time out after 29 seconds. Whereas with Application Load Balancer and with function URLs, you have that 15 minutes. Okay, so you can serve up data that takes more time to process, stuff like machine learning inferencing. There's also a really interesting mode in API Gateway that allows you to generate an SDK from your API. Now, in terms of cost, this is another big point of differentiation, okay? Function URLs is free to use. You still pay for the invocation of Lambda, but you don't pay to access that Lambda function, whereas application load balancer runs on an hourly plus capacity unit, so it's not completely serverless if you're a real purist in that sense. And API Gateway has its own billing model as well, which is based on how many requests you use essentially. Final point of difference is that API Gateway and Application Load Balancer work with AWS WAF, whereas Function URLs does not. So here's my kind of summary for you, if you like. I would say use API Gateway for the direct service integrations to reduce code, because you can add that routing logic into API Gateway and not in your function code. You can build both REST and WebSocket APIs, and you have additional security that you're able to permiss around accessing your business logic. Application Load Balancer, on the other hand, is ideal for hybrid applications that might use Lambda and EC2, and for migrating between those services is a really good option. Function URLs is great for getting started with serverless, getting started with Lambda, ideal for simple invocations of Lambda, things like web applications, and because of that different cost model and that 15-minute timeout, it's great for longer running workloads. So just to recap, we talked about function URLs, this new simple way of synchronously invoking Lambda functions from an HTTP request. We talked about the difference between asynchronous and synchronous invocation models. Now, I would say as a default to use an asynchronous invocation if you don't need that immediate response from your Lambda functions. Serverless seems to work fantastically well with asynchronous in an asynchronous mode, where you will submit a request, receive an acknowledgement, and then grab the result of that request later on when it's ready. We didn't touch on this too much, but when you want to optimize your Lambda function, it's best to initialize any resources that you're going to use above the function handler code and try and minimize the deployment package size of your overall Lambda function to help you get some sort of performance optimizations there as well. Thank you so much for listening to this talk. Please do go and dig into some of those further reading resources that I posted throughout the talk, and I thank you for your time.